समस्त को आज आईएलएस प्रथम दिन में समस्त को स्वागत करुच्ची आ विशेषकर आम विश्वविद्यालय कुलपति माननीय श्री संतोष कुमार त्रिपाठी महोदय, स्नातकोत्तर परिषद अध्यक्ष प्रोफेसर संतोष कुमार अजवाला तथा आज आईएलएस मुख्य केंद्रबिंदु तथा आकर्षण प्रोफेसर प्रकाश चंद्र मिश्र सर आम विश्वविद्यालय समस्त सहकर्मी विशेष कला समस्त को आज सभा स्वागत करुच्ची। जे आईएलएस जो इंट्रामुरल लेक्चर अच्छी एटा नुआ नुहे, एटा तार गोटे द्वितीय रूप रे आसीची। जो द्वितीय रूप रे केमती आसिला सेटा हला केवल संभव ही परिची हम कुलपति सारंकर जो गोटे बहुत सामग्रिक विजन अच्छी, विशाल विजन अच्छी ए विश्वविद्यालय पई हमर जो कुलपति अध्यक्ष महोदय स्नातकोत्तर परिषद अध्यक्ष महोदय जो गोटे बलिष्ठ सांगठनिक संरचना अच्छी दुई जन सम्मिश्रण रे ये कोनी नुआ रूप रे आप सामने को आछि। मु आपण मानन को ए जो नुआ रूप आईएलएस रो सेते समस्त को समस्त सहयोग कामना करूछि। एथिरे आमे वर्तमान दुई पद सुनिबा हम अध्यक्ष महोदय को प्रोफेसर
esteemed Vice Chancellor Dr. Santosh Kumar Tripathi, my dear colleagues, my dear research scholars. It is the revival of the internal lecture, which is the brainchild of our Vice Chancellor. But we try to make it in a new form. We want to make it in a systematic manner. सात सेटा को हमको आगुरु कहिथिले जे ताको हम सिस्टमैटिक मैनर करि तनो से भितरे फास्ट असला हमें डेट और टाइम फिक्स करिछु। प्रति मास रे जो माने देबे सेमानकर ना हमें लॉटरी माध्यम रे बात करिछु आ से ना गुडा आपन को प्रति मास रो फ्रंट रे ना गुडा बाहरी समस्त आ आपन माने निजो टॉपिक जो ना बाहरी टॉपिक गुडा हम जो कोऑर्डिनेटर अछंती दुजन रवि सर और विश्वजीत सर को हम प्रोवाइड करें अनुसार नोटिफाई करें। या भितर बहुत अट्रैक्शन अच्छे। फर्स्ट अट्रैक्शन है आपण मानकर पूरा टॉप वीक का आमे सोशल मीडिया रे आपनकर डिस्प्ले करू हला फेसबुक इंस्टाग्राम हम जहां जहां सोशल मीडिया अछि आमे जरूर ग्रोथ करू। सेकंड है आपनकर टॉप रिकॉर्डिंग रहिबो जोटा कि यूट्यूब चैनल आपनकर यूट्यूब चैनल जोटा अछि यूनिवर्सिटी रे सेतरे रहिबो से पूरा टॉप का। थर्ड रहला हम गोटे एप्रिसिएशन सर्टिफिकेट वाइस चांसलर तरफरु जे टॉप दबा तांकर प्रोवाइड करू। फोर्थ रहला आपनकर हम गोटे फॉर्मेट प्रोवाइड करू जोथरे आपन निजे टॉप का रेटिंग फॉर्म रे देबे व्हिच मस्ट बी प्लैगियरिज्म फ्री सेटा को हमें चेष्टा करू आईएसबीएन को किबा हम यूनिवर्सिटी जर्नल रे पब्लिश करबा। इतना सार अनुसार हमें फाउंडेशन डे ई फाउंडेशन डे नुआ नेक्स्ट फाउंडेशन डे 27 फाउंडेशन डे सिलेक्टेड बेस्ट टॉप को अगेन हमें अवार्ड किंबा एप्रिसिएशन दो बेस्ट 3 बोले सर बेस्ट 3 टॉप को हमें अवार्ड दो तेणु इटा किना अट्रैक्ट करिया में बा इंटरेस्ट बढ़ेवा में रिसर्च स्कॉलर माने मध्य चेष्टा करूछु आ गुटे सीरीज आरंभ करियो फॉर द रिसर्च स्कॉलर से मान यदि निज आडू किछि इंटरेस्ट देबे निज टॉप को करिवे कारण इट इज द प्लेटफॉर्म टू प्रैक्टिस माने आपण माने निजे चेष्टा करि परिबे टीचर मान का आगे करिवे तले निज प्रॉब्लम ता बुझी परिबे। और सेकंड है और ए प्रेजेंटेशन जो मेन आउटकम होची इंटरेक्शन मो टीचर मान को ना हिसाब रे जानि डिपार्टमेंट हिसाब रे जानि কিন্তু একদিন ମୁଁ ଜାଣିନି ତାଙ୍କର actual expertise of field of work ତେଣୁ this is the right platform to know the field of work। हम सार ଆମେ ଚାହୁଁଛୁ ଯେ ଆପଣ ମାନେ ଯଦି interact କରିବେ आपन रिसर्च जो लोक आपन को टॉप को इंक्लूड करि परिबे ताले आमे एठी बसिबाटा सार्थक हबो आ आमे जो चेष्टा करछु सेटा सार्थक मु देखुची बहुत जन निजे आसी ताला आमे चेष्टा करिबा जेंति आमे बाउंड करू सीएनईएम टू आमे बाउंड करू आपन को देह खराब न हो तेनु मु चेष्टा करी कि आपन माने निजे जोटी भी थिले चारटा पुलिस जदि भिडी आसी परिबे ताले आमे एथिरे सफल हेल्प करू तो थैंक यू ऑल आमे चेष्टा करू कि एको आपन मान को हेल्प अनुसार आगो बढ़ू थैंक यू
वर्तमान में भाइस चांसलर सर को रिक्वेस्ट करको
धन्यवाद देवी सांगठनिक तत्व बंधु माने पढ़िले जाय हमें पुलिस आरंभ करबा इंट्राम्यूरल यार उद्देश्य है जे मो मोर परिचय देवी मो पाठर परिचय देवी मो प्रथार परिचय देवी मो विषयर परिचय देवी ता संगे मैं आशा करी जे मोर बंधु माने मते सहयोग करिवे मते आगु को बढ़ेबा पाई प्लस मोर साहाय्य लेबे सेमाने आगु बढ़ेबा এই मुख्य उद्देश्य सह এটা आरंभ है परिचय प्रधान उद्देश्य जे परस्पर को जानेबा परस्पर को पाठ को जानेबा এবং से पाठ मते केमति साहाय्य करियो से विषय भी जाने मते खाली साहाय्य करियो ता नै मो जो सोसाइटी रहउची सेठी किछि साहाय्य लागि करियो से विषय भी जानेबा आग्रह रखबा एठी असला जो बेसिस चैलेंज बोली संतोष सर कहले सेही बेसिस रे चले मजा कथा हला जेना हमें प्रथम लॉटरी कर टोटल जीवन पाखर दीटा डब्बा थई गोटे डब्बार समस्या ना पड़छि आ गोटे डब्बार चारटा बाहरी पड़छि सेटरे ऊपर लिखा है फिनिश तो से जो लॉटरी जो उठेबा कथा चलो मो उठे प्रकाश सारी उठे चलो उठेला प्रथम बोले जोर बारे चली बढ़िया तो এই সিস্টেম রে চালিলে মো ভাবছি বহুত ভালো হবে আমি যে থুলে সেদিন রহিবে লাস্ট দিন যে প্রটেক্ট করে সেই উঠে তার নাম উঠে বলে কইও প্রকাশ স্যার को से भाई लकी चाय बोली कयो ना तांकर से बहेनी करछे तो बहेनी जेतो भलो होई छि निश्चित भाव रे आगु भलो होबो हम समस्त आशा रखबो पढिबा पढेबा शिखिबा शिखेबा ए उद्देश्य रे आगु आगु बढ़े बहुत धन्यवाद
सारंग को लेक्चर सुनिला को गुरु खाली सारंग को विषय रे दुई पद कह देबी तांकर आमे जानतो सारंग को तथापि प्रोफेसर प्रकाश चंद्र मिश्रा is a professor in the Department of Environmental Science at Contaminated University. He earned his PhD from NIT Rourkela, specialized in water quality monitoring, fluoride, migration, coastal aquifers, environmental materials, and he also associated with many projects. He completed so many projects. Not completed, he's also doing those projects now. ANRA pair projects, OMBRICS projects, BRNS, and many things associated with COE in our university. And second thing is about him is very important is he is one of the faculty member of this university who is done so many things for this university through his research, innovation, teaching and institutional leadership. With this brief introduction, I invite Professor Mishra to deliver this lecture.
Esteemed Vice Chancellor, Dr. Sundar Tripathi, Chairman, Coastal Council, Dr. Sundar Tripathi, Medical Professors, Scholars, and students. So, this sample actually मुही मोर लकी ड्रॉ करथिले आ मो फॉर्चूनेट एनाफ दैट फर्स्ट टाइम मोना नाम रे आ सिटको भाबुथिले जे का मोटे ही बात पारि बोलि कि रिजल्ट से आइबा मोटे ही बात आ तेनु सारी धन्यवाद देबी और निश्चित धन्यवाद देबी जे मोर फर्स्ट करछि हम साथी बा कहले बहुत भलो हेले आकु भलो हो तेनु चेष्टा करबा में हमर जो 40 के हमर मिशन जहां अछि हमर मोटर जहां अछि कंप्लीट करबा ଆଉ ପ୍ରତି ସପ୍ତାହକୁ ଆମର ଇଣ୍ଟରନାଲ ଲେକ୍ଚର ଆମେ ଚାଲୁ କରୁଛୁ। Who I chosen this topic because I am working on this. So I import in technological approaches for import of contaminated water. So what talk को जब हम बोलो वो एक जिसको पहला पे चाहिए 80 क्लास से पढ़ी फाइल से is it clear? Let is a question mark. It is clear actually मैं जानना हूँ. Is it water which we are purchasing in bottle, that is aquafina or whatever it is coming in the market, is it pure? It is also a question mark. So unless it is analyzed, you cannot say which one is pure and which is not. In 2004, there was an exploding news that the cold drinks and packaged water contains pesticides. So if the packaged water or cold drinks contain pesticide, then this one is far better. It will be coming from our tank by filtration through aquaculture. Second thing, if the water is treated by this aquaculture, is it pure water? It is also. So all the water which is consuming by us, that must be analyzed first. Then only you can say which one is pure, which one is not. Because you can see in the water bottles, it is clearly written not to expose in direct sunlight. Although it is mineralized water, RO water, hydrosulfurized water, whatever it may be, the treated process. In clear, they written not to expose in direct sunlight. If the water bottle is exposed in direct sunlight, then leaching the metal happens. That means the bottle water may contain heavy metals, lead, chromium, lead, nickel. So these are the metals present in the water. So you cannot say that that water is pure. So we must analyze first, then we should have to take. Whatever it will make your plant. So আমি এখন জানতে ছোটবেলা পড়তে নলকূপর পানি পিবা লিখি ছাড়ে ছোট নম্বরের স্কুলে লেখা আমি ভাবছিলাম যে নলকূপের পানি হচ্ছে পিওর আজ আও সেই সেন্টেন্স ভুল প্রমাণ পেয়ে গেছি কারণ নলকূপের পানি পিওর নয় কারণ অন্যগুলোর কথা আমি ভাবছিলাম কোন যে সয়েল ইজ একটা যে বায়োলজিক্যাল ফিল্টার সো ইট মে ফিল্টার all the metals, non-metals, equivalents, aquatic, microorganisms. But now, the underground water is being polluted by different water pollutants. It may be fluoride, it may be iron, it may be lead, it may be other water pollutants. So, we can say the underground water is pure for drinking. Underground water, borewell hope to pure host, pure constant paper. But now it's not guaranteed that the underground water is pure. Yes. So the object of my talk is introduction what an intention of fluoride toxicity, available technology to fluoride remediation, scope for new materials and methods, prospective solutions developed by my institute. So ମୁଁ ମୋ କାମ କ'ଣ କରୁଛି ତାକୁ ବି ପ୍ରେଜେଣ୍ଟ ପାଇଁ ଯାଉଛି ମୁଁ କ'ଣ କାମ କରୁଛି ତାକୁ ବି ଦେଖିବା ପାଇଁ ଯାଉଛି So I have called fluoride by Yauchi. So fluoride is the 13th most abundant element in the earth. First is the oxygen, then silicon, aluminum in iron, and 13th is the fluorine. It is highly reactive and only found in organic fluorides and inorganic fluorides. It combines all elements except oxygen and lovely gases. So it reacts with oxygen to form O2, but as fluoride is the most electronegative atom, oxygen becomes O+2. So it's not stable. Inorganic and organic fluorides are present in soil and minerals in water. And fluoride, chloride, graphite are some of the examples. But mineral containing the fluoride, fluorine is fluoride. So your different sources are there for the presence of fluoride in the groundwater, like glass industry, fertilizer industry, cement industry, volcanic eruption, coal-fired power stations, electric. So many sources are there which are anthropogenic, and also there are some natural sources are also there for the contamination of groundwater by fluoride. Yes. So from many sources we are taking fluoride into our body, like from drinking water, from soil, from toothpaste, from air, from different medicines, beverages, and food. So from many sources we are taking fluoride, and when the concentration increases, it will affect our body. So fluoride, if the let me say the as per WHO, World Health Organization, the permissible limit for fluoride is 1.5 ppm. If it is more than 1.5 ppm, then it creates problem in the body. So as per ICMR, BIS is 1 ppm, but as per WHO it is 1.5 ppm. If the concentration exceeds 1.5 ppm, it creates problem, and fluorosis is the major disease for this to take containing water and food. Next. So this is the if we take fluoride up to 1.6 to 1.9 milligram, then 1.0 to 1.4 milligram per liter will be eliminated from urination, and rest part will be accumulated in the body. So if the concentration will be 0.002 milligram per liter here, then there will be problem with vegetation, 2 to 5 milligram per liter problem, and if it is 2 to 5 gram per liter, then there will be the liter. So the main problem in the fluoride is you take high concentration fluoride content in water when you food, then it creates problem in the bones and teeth. So there will be skeletal and dental problems. It is known as fluorosis. So high concentration for the skeletal and dental disease, that is known as fluorosis. And again, it also causes arterial disease, which is also caused by the the presence of fluoride. And this is the first one is normative, and severe is the last one. The concentration of fluoride will be more. So one thing which we noted here, fluoride we should take some kind of concentration of fluoride. If fluoride not there, then there will be problem also in the teeth. That is known as pylea. It differs for the enamels. And if the concentration increases, then also it creates problem that is known as fluorosis. So sometimes doctor prescribe to use fluoride containing paste. So here when it needs so we need also fluoride and zinc because of our body. And if it exists, we need to be compromised. So this is the effect of fluoride on different organs of the human body. So it also affects the brain as well as you can see the kidney. So this is the works in the area of fluoride contamination. So more than 100 nations are affected by fluoride. And South Africa is putting most Asia 39, followed by Asia 28, Europe 25, South Africa 5, North America 3, and Australia 2. this is the status of India. Around more than 21 states are being contaminated by fluoride and also affected by the fluorosis. So these are the states. So you can see the Tamil Nadu, Telangana, Andhra Pradesh, Gujarat, Haryana. These are the most affected states of India. And Odisha also it is also in the position. And Gujarat, Balasaur, Bhadrak, Bhadrak, Bhuj, Cuttack, Jajpur are also contaminated by fluoride. So these are the districts which are contaminated by fluoride. The red mark highlighted, which are severely contaminated by fluoride. Bhadrak, Balangir, Balangir, Nopada, Ralahandi, Khordha. So in Khordha there is a village, Balasingh and Singipur. So that village is contaminated, high contaminated fluoride. The surface of this village is also the concentrated fluoride more than 4 ppm. Although permission is 1.5. And in Nopada district, there is Bodal block. Bodal block is also highly contaminated by fluoride. Next. So more than 21 districts of Odisha is contaminated by fluoride, along with Balasaur. So in Balasaur, 4 blocks are severely contaminated: Balasaur, Sadar, Ramuna, Boston, and Bhogay. So status of I'm working on this Balasaur. I'm training Balasaur district, so I'm highlighting this whatever what I have done for this Balasaur district. So as you can see the going into district can be divided into 3 geographical regions: the coastal belt, inner plain, and the hills of the southwest. And the limit of the area is controlled mainly by Bunavaranga, Subhadalekha, Panchapada, Kansavansa, Sonam, and Jamia. And the Singhum granite, Panjal granite, granite, unrelated cliffs, and Dolomite and the laterite rocks are the main type of rocks found in this area. So geology department can better explain this. And the depth of water level is depth from 6 and 8 megabg. Next. So these are we collected more than 170 samples from the different places or villages of the Balasaur district. And these are the next. We have district generalized geology and 3D flat diagram of geological location of Balasaur. Next. So these are the areas that are principally affected by fluoride. You can see some regions of Jairam Panchayat of Bhagrai block, Rupsa town, Potwajira Panchayat of Basta block, Machha of Nilgiri block, Potkibar Panchayat of Ramana block, and Chandipur of Balasaur Sadar that are affected by fluoride. We got the considered varies from 0.06 to 7.10 ppm in 2023 and 0.1 to 7.51 ppm in 2024. The concentration of fluoride in the university campus is varies from 0.8 to 1.3 ppm. So the status of this one is also in alarming condition. It varies from 0.8 to 1.3 ppm. As per the analysis we have done in our laboratory, also the testing the outside laboratory. So this map indicates that the northwestern and northeastern part of Balasaur have less risks of fluorosis, while eastern and other parts are higher risks of fluorosis. Next. So these are the dental screening program of Jairam Panchayat which in Bhagrai block. So this is in alarming condition now. So what should be the action plan to provide safe water to the community or villages? So two things we have to see whether safe water is available. If it is not here, what should be done? So if safe water is not available, then we have to plan for alternate arrangement. If it is there, then awareness program must be carried out so that that will not use that fluoride contaminated water. So different techniques are available for the removal of fluoride. So for different reason, adsorption is available, manual technology is available, and coagulation process is available. So which one needs to be chosen? So the adsorption process, we can use activated alumina, different materials containing oxides, zeolites, layered wood hydroxides. So these materials cannot be used by the rural people directly. Manual technology is not cost effective. Coagulation, there is some disadvantages. So hospital. So if adsorption is carried out, this is a mechanism. We will choose a suitable adsorbent. So here iodine may be carried out for the removal. Hydrogen will be there. Electricity attraction will be there. Porosity, due to porosity, there will be some attraction with this current and will be there. Surface adsorption will be there. And it may form some complexes with the fluoride. So different adsorbent like bentonite, zeolite, nanomaterial, signite, biochar, carbon will be used as an adsorbents. So many researchers have carried out different their works by using different materials like dioxin, fungicide, alumina, red mud, limestone. So many methods are available. So few examples I give here. Also, the chimney is used for the removal of fluoride, lime, and there was a method of galvanic techniques which are used in 1974. It is developed by National Environmental Engineering Institute. But Nalgonda is the place in the Andhra Pradesh, and the Krishna River, the concentration of fluoride was very high, and they used alum, potassium aluminum sulfate, as a coagulating agent for the coagulation of fluoride. So before using this coagulating agent, the water should be treated with lime. So fluoride will be restricted to calcium fluoride. Then aluminum sulfate was added as a coagulating agent, and then the microorganisms are destroyed by using bleaching powder. So this procedure was widely used for many years, but due to the presence of aluminum and sulfate, there was health problem. So this process is completely banned. So aluminum was reagent in the water is aluminum sulfate, and sulfate also creates captured powder. So Nalgonda process is completely banned, and now it's no one uses this Nalgonda techniques. So what do we take to make fluoride technology more successful, and which materials and methods can capable or enable safe water access for long term? What material and technology is fit for sustainable household use, and also the opportunity and challenges to design the material according to the need and hence to study their adaptation characteristics. And ongoing research on similar field of study highlighted the possibility to explore and hence the opportunity and challenges to design newer kind of adaptations according to the present need. So different membrane processes are also available for the removal of fluoride from water. So polyamide membrane, cellulose acetate, hydrogen sulfide, acrylonitrile, membranes are available. Also, nanomaterials are also used as an adsorbent for the removal of fluoride, because nanomaterials are high specific surface area and so high activity, variety in pore structure and hardness, magnetic characteristics, have surface and volume ratio, cost effectiveness, chemical stable, a low reduction. That's why nanomics can be used. So what I have done for the removal of fluoride that I am highlighting. So I have prepared polycyanide sodium phosphate with an adsorbent for the removal of fluoride. So in the laboratory, we prepare by using cinamide and ferric nitrate to form polycyanide sodium phosphate, which are used for the removal of fluoride, which is protected by using nitric acid. So the mechanism is stated here. So it may on and NH3 fluoride will be formed and fluoride will be removed from the water due to the electricity infection. There are also use red water. Red water is the waste product of aluminum industry. The red water is neutralized with a high alkaline and it is neutralized and then it is heated or activated by using thermal at 600 degrees activated by using high temperature and used for the removal of fluoride. Also, you have used mucilage for PRAKASH and use sodium arsenate and ferric chloride to form nanocomposite. And this gallium composite is used for the removal of fluoride. And also, we got filtered result for the removal of fluoride. Next. So, this is the mechanism. Sodium arsenate, ferric chloride, and dry-gelling mucilage from PRAKASH and at pH less than 6.5 and pH greater than 6.5, the bioconjugate absorbs fluoride and shows better regulatory characteristics. Also, it used KD polyethylene for the removal of fluoride. So it is activated and added APPs and this bioequivalent also removes around 93% fluoride from the plasmodium. So then maximum reducing cost was found to be 80.8 milligram per gram at neutral pH. Next, so this is the mechanism for this graph. Also used the calcium oxide gas polyaluminate nanocomposite for the removal of fluoride. So here also we got additive capacity of 186.5 milligram per liter, which was very high, which implies the characteristic of good adjuvant. Also you need stone powder, which is collected from biocellulose and nearby iron process and try to remove fluoride from the plasmodium and successfully remove fluoride. So this is by using stone powder and polyamide. Also we use kusumo. It is kusumo. This is the work of Sivanya. So here also we achieved quite good removal of fluoride. The fruit is treated with sodium carbonate and the charcoal is prepared. The charcoal is activated by using sodium carbonate and using an adsorbent. So the mechanism is shown in right hand here. So here also remove 93% of fluoride from atmosphere. So not only I am working on this fluoride, but also I am working for the removal of arsenic, lead from atmosphere, and many adjuvants were prepared for the removal of all these adjuvants, especially copper plants, and quite successful in the removal process. Thank you.
And this question, which question can you answer?
Indeed, a nice talk and my question is from the last example. Why should I want to add sodium carbonate on this? What is the chemistry behind it? Why should I not use the raw one? Or for example,
Right, sodium carbonate you use it for activation.
yes.
So sodium carbonate is only for the activation. You can use that zinc oxide.
What is the chemistry behind it? Why should I activate this raw material? First of all. What is the next question is why should I activate it? What is the parameter to target so that I can know that activity will work?
If directly will use heated material in the furnace, then only you can get the charcoal. But the surface area is less in charcoal. If it is activated, the surface area will be less. The activation process can be done by different processes available. You can use sodium hydroxide, sodium carbonate, you can use alumina, phosphoric acid, you can use zinc oxide, many materials can be used for the activation process. Okay, so why here sodium carbonate is used? So we are trying to make some edible products which can be directly used for the activation process. Suppose I am using sodium hydroxide. So if sodium hydroxide will be there, that if one knows that the material contains sodium hydroxide, then there may not use for the adsorption process. But sodium carbonate, sodium bicarbonate can be used when sodium bicarbonate is edible. So sodium carbonate, sodium bicarbonate can be used for the adsorption process.
In that case, what is the before activation? What is the procedure?
Later,
Yeah.
very poor, around 70%.
27.
70%.
Thank you.
already ଗୋଟେ question ଯୋଉଟା ଆମେ ଯୋଉ fruits यूज କରୁଛୁ
Fruit,
ଯେଗୁଡା यूज କରୁଛୁ ତାର କଣ ପାରାମିଟର ଅଛି?
calcium based material is best for removal of fluoride. If calcium की वो source है, ताहले भलो से removal करने को fluoride. Calcium is easily accumulate fluoride. ଆମର କାହିଁ ସ୍କେଲିଟल ଲିକ୍ କାହିଁ ହେଉଛି ଆମର ଡେଣ୍ଟାଲ ଲିକ୍ କାହିଁ ହେଉଛି ବିକଜ ଯେତେବେଳେ ଫ୍ଲୁରାଇଡ୍ ନେଉଛି ସେ accumulate କରୁଛି ବୋନ୍ ତାକୁ ଫ୍ଲୁରାଇଡ୍ କ୍ୟାଲସିୟମ ଦରକାର କିନ୍ତୁ କ୍ୟାଲସିୟମ ଫ୍ରି ରିଭାଇଜେସନ ବୋନ୍ କୁ ପ୍ରତି ହେବ ସେ ସିଙ୍ଗିଲ ତାକୁ ଆଟାକ୍ କରୁଛି so that's why ଯଦି ଆମର ଯାହାର ଫ୍ଲୁରାଇଡ୍ ଆଫେକ୍ଟେଡ୍ ଏରିଆ ଥିବ ସେଥିପାଇଁ କ୍ୟାଲସିୟମ ସପ୍ଲିମେଣ୍ଟ ଦେବା ତାହେଲେ ଫ୍ଲୁରାଇଡ୍ ର ଆଫେକ୍ଟ କମିଯିବ so we can use either to vitamin C रे संगे अपन कैल्शियम देबा इवन we can use जोटा सजना साग आमे सजना संगे पाउडर हम गोटे कमिटी अछि डीए अछि हमर मिनति में डिस्ट्रिक्ट मेंबर अछि डीएफएलसी डिस्ट्रिक्ट फ्लोराइड मिटिगेशन कमिटी अछि जोटा डिस्ट्रिक्ट अपन कलेक्ट सब कलेक्ट अछि चेयरमैन से कमिटी हम प्राइम मीटिंग अछि माने 3 मास 4 मास 6 मास मीटिंग हुए जो जो एरिया हमर बालसो डिस्ट्रिक्ट रो फ्लोराइड कंटेमिनेटेड एरिया अछि सेतरे सुबले इंडियन के एनजीओ अछि से इंडियन एनजीओ सेते ड्रम स्टिक जो सजना साग रो पाउडर के टैबलेट कैरी करा अछि से टैबलेट और कैल्शियम सप्लीमेंट सब ता कारण अछि यदि हम फ्लोराइड कंटेमिनेटेड वाटर इंजेक्ट करछे ताले कैल्शियम सप्लीमेंट देबा ताले जोटा हमर कैल्शियम का फ्लोराइड का बोल पे करता कैल्शियम सप्लीमेंट से अटैक करता ताले बोन पूरा उसी करना होगा और सजना से टैबलेट यूज करने के कोआगुलेट है सेटा को बांधी के जोड़े साथ करता तेना हमें चेष्टा करछु फूड जोटा हमें एडिबल मटेरियल को यूज के करिवा ताले नेक्स्ट लास्ट क्वेश्चन होगा लास्ट तापर So our target is edible product to Nabu, Pakavansi or Potiban is a feedback. This is the target. The edible material Nabu is available. Only chemical not use not. This is the target. If you are working, the bahar में किसी एलिमेंट रहेगा, get के remove करेगा. This is the target.
How you are measuring the level of contamination of water contaminated by fluoride?
Right. Sir, different methods are there, but we are using iron-static reactor.
I mean level of contamination.
Concentration.
Yeah.
Sir, pollution level is 1.5. If it exceeds 1.5, then you can say you are suitable for treatment. So we are using instrument for the density concentration.
Okay. So one more question. Like you are using artificial neural network. For what purpose you are using?
Sir, just to verify whatever data we are getting and what the machine learning tests. Just to verify the data. So different algorithms kinetics, equilibrium, concentration we are calculating, and that data will be verified by this neural network.
What type of artificial neural network you are using?
Sir,
I mean there are
yes,
various
various types of. Sir, we are using sir.
RSM is applied.
No.
RSM also here. In
See, RSM is not artificial neural network. This is just a function to measure the error.
Sir, in one paper we test both RSM as well as ANA. Yes.
No, ANN. I will
Yes, sir,
what
yes, sir.
type of ANN? I will do back propagation
Yes,
or
sir.
maybe multi-layer perceptron with back propagation.
Multi-layer.
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 Okay, thank you.
Yeah, of course, it's interesting talk. Looking in the audience, like those who be thinking of fluoride in future, how it is going to be contamination, remediation technology. Of course, I am working with equal mission with SAP together in another project, just kind of in a global context. I want to have kind of one theory in that. As you know, in chemical technology, in a discussion with scientific board, they were asking about most of the fluoride contamination remediation they are strategically applying for alumina specifically, right? And as you understand, we are talking about remediation. Certainly, it is come together, it's like river, like it will be pond, it will be water bodies. So targeting such kind of a bigger system is very difficult to develop such kind of absorption technology, though we are successful in basic model. So how do you see the future? Particularly we are developing technology utilizing bioresource, maybe encapsulation, nanomaterial or biochar and blah blah blah. So how do you see in future, coming 10 years, down the level 10 years, how is sustainability of this technology ahead of the existing technology of alumina, zeolite is there, and other materials based on alumina. So that your views on that.
Alumina is quite costly. It's not cost effective. Alumina can be used, but it is not cost effective. Zeolite can also be used. But for near future, it's quite difficult for the removal of fluoride because almost all methods have some advantages as well as disadvantages. We have to reduce the disadvantages. We have to think on that, how to reduce the disadvantages. Because alumina process, alumina is used. But when the alumina process is used, because believed to be a marvelous process. But later on, it indicates the alumina is there. Sorry, aluminum is there in the water as a residual. So alumina had so that's why that process is now not generally used. So most of the processes have some advantages as well as disadvantages. That should be we have to take care of.
You are using filters for filtering the water. Is it possible to modify the filter where we can directly filter the fluoride content?
Alright.
Because if the water is fluoride contaminated, now the RO process is there, reverse osmosis process is there. So if you develop one layer above the filters, then it is possible to remove the fluoride content.
That is possible. But eventually, some degrees are there. So right now, check on you. So much more example. Sodium chloride. Sodium chloride, you can remove calcium, magnesium by using sodium chloride. Sodium chloride can use the medium. The hard to pass to the medium. So calcium can substitute sodium. So calcium will get absorbed by the subacid medium. Then you can get clear water. After a few days, calcium, the sodium chloride becomes calcium chloride and it becomes PROF. It will pass hard water, then it cannot get salt water. Okay. Then again it should be degenerated. Again it will pass sodium chloride solution, then it becomes sodium chloride. So likewise, suppose one material is there, fluoride comes up, and production will pass over there, fluoride can go deeper, then one method should be there for the removal of fluoride. So these are the difficulties.
Good afternoon, sir. Thank you for such informative talk. I have one question that suppose we are seeing water we are using at home, suppose the water is whitish in color and the TDS is high, so that means it is having fluoride.
Not necessarily.
Not necessarily. So is there any way that at home also we can come to know that it is having
Fluoride cannot have, if ideally check, you can check, how. Balasar की जगह अच्छी तरीके की हाँ
Madam, fluoride is water solid, so you cannot see the fluoride in water. So you have to taste in a separate method. So if you want to check your water, just take your water to our laboratory. We can see what fluoride level is.
after reduction you know identity वाला तो अच्छी अपन नहीं मिल सकता identity का प्रॉब्लम कंटिन्यू रखिए सकाप से बैलेंस करेगी तो ऑयल मस्ट फिर अच्छी इंडिकेशन ऑफ प्रेजेंस ऑफ आयरन.
Another question, does this fluoride have any impact on hair and skin also?
Yes. So बटे इंट्रोडक्शन में वो क्या है हमें समझते हैं आरोग्य यूज कर सकते हैं रिवर्स ऑस्मोसिस रिवर्स ऑस्मोसिस का काम होती है से वाटर को डीमिनरलाइज करना मिनरल फ्री करना जो हमारी कंपनीज के लोगों से दिए सारे देखिएगा आपको वो रो वाटर देंगे 200-500 देखिए वो TDS आरो लगेला परे तब टेस्ट करा पर से देखो 50 देखिए हमें खुशी जाउछे जे हमरो 200 के 500 थे 50 हे गला कारण इंस्ट्रूमेंट काम करूछि कि 50 से देखो जे हम बॉडी टेक्सचर प्रॉब्लम होछि वी नीड एट लीस्ट 200 ppm TDS फॉर मिनरल्स सम बॉडी को जे मिनरल दरकार आजकल डॉक्टर का बोले ज्वर होला को डॉक्टर तो छुट्टी मिनरल्स किंवा विटामिन्स ता कारण होछि डॉक्टर जानि छथि जे हम घरे आरो लागि छै यदि आरो लागि छै हम बॉडी रे मिनरल ना तो जो माने आरो यूज कर सुनके ताको मिनरल का सप्लाई करा होछि से कोन से मिनरल ऐड करा होछि बोले कि ताको एडजस्टमेंट का 20% करा मोस्ट ऑफ की आरो 50% तो 50% हम बॉडी के मिनरल से होना तो सीधा देखिए
So nice presentation. So many things put it in a very short time period. So my question is you said there is a spatial variation seasonal. Let's say pre-monsoon, monsoon, and post-monsoon. So what is the variation? So what are the triggering factors? Second question is have you done any temporal studies of the surface and groundwater? Because there must be a variation.
The most of the quality of groundwater.
Yeah, what I am talking about because if you go to the coastal area, lot of salt water diffusion is going. So that is why you have to check, is there any variation? Third point is you have so many, outputs or technology where you can get rid of these, fluoride. So do you have any case studies where you have used this thing or validated your technology and you have reduced? I think whatever you are claiming, there can be any case studies where some kind of validation or some kind of statistics you have put into so that you have reduced that or that particular technology is effective. Maybe it's effective in the lab. So is it effective in the ground?
Yes, sir. Quality testing. So the variation is very not very high, but some variation is there in different seasons. and the materials are already tested there by increase of polluted water, collective polluted gases.
So what are the triggering factors?
Any changes which is happening, because one slide I saw that most of the triggering factors are human made. Only one is volcanic eruption which you observe. And in India there is no place where volcanic eruption is happening. So if it is human induced, so is it better to work at the source or at the end?
So if you do abstract water from groundwater continuously, then water level decreases. Then there is dissolution in the water level with the mineral dissolution in the groundwater. So that's why it also get various on the fluoride to groundwater. It also genuine.
Good afternoon, sir. As you said, there is a effect of fluoride in the oral and particular teeth. The photograph shows some effect, a particular effect, a specific site on the teeth. What you have shown in your photographs. See, when I was saying that this fluoride contain absence of this fluoride content in the body, that will see pioneer, like you said, specifically caused by this spidism, and some other protein also device in other species. So, how we are going to clarify that this effect is particularly this absence of the fluoride or it is something else? See, in the physical appearance, we could not conclude. Is there any symptom that fluoride causes this kind of conditions in the teeth?
So the anomaly of this calcium hydroxyapatite. In our teeth contains hydroxyapatite. So if fluoride is event, then there will be no mineralization of the hydroxyapatite. That's why doctor gives some fluoride content test. So to stop the demineralization process, demineralization process of the teeth, fluoride is necessary.
The same scenario found in this case, where the bleeding is another symptom, but the same initial symptoms will be like this one.
Again,
so that's what I'm asking. The regular symptoms are quite similar to fetus type of disease. This is associated with the oral the root of the kind of crown portion of the teeth. That's why
it's a crown. Yes, crown.
Thanks.
Thank you, sir, for this beautiful presentation. One of your slides mentioned about schizophrenia. You mentioned about that because of fluoride, schizophrenia and epilepsy and Alzheimer's is affected. So, sir, how could this affect neurotransmitter system, specifically dopamine pathway? So, my question is,
there is a similar condition disease. Due to this aluminum fluoride, I consume aluminum fluoride intake. It causes critical question about how it decreases the dopamine. There will be some reaction to be there. It stops next of the secretion of dopamine.
Good evening, sir. I have a question. Biochar has been used for the water filtration. Sir, usually biochar is hydrophobic in nature. So, has it gone through some of the post-treatment methods so that it will become hydrophobic in nature? After doing that, has it become hydrophobic?
Yes, okay.
So,
It can be done.
can be done, sir.
Yes. So many methods are there that can be used. Thank you very much.
सर को बहुत धन्यवाद जरा चिल्ला के 16 वर्ष है जा पोखरे गाधो बहुत पोखरे प्राणी भी पी जाइए तापर कूप पानी पिया होतला तापर नळ कूप पानी तापर असला जो बाक्स एतोळे बाक्स पानी पिलो तो देह खराब जेबेटु बाक्स पानी पिली सेबेटु देह खराब प्रकाश सर आज जहाँ कहले बाक्स पानी भी ठीक नहीं तो पानी का स्वच्छ हवा कहले आप तार विधिगत व्यवस्था करे पड़ो मोर अनुरोध रह प्रकाश सर जो रिसर्च करचंती सेठी शीघ्र करंतु सदा टोटल बा मेथड किछि बाहर कले आप नारिशर को फ्लोराइड कंटामिनेशन को रक्षा करि पारे ए अनुरोध सह मो प्रकाश सर को बहुत बहुत धन्यवाद देबी एना प्रथमे कहबाटा बड़ कष्टकर बात प्रथम स्पीकर हिसाब रे से जो साहसिकता देखिए सबको बहुत धन्यवाद शुभलक्ष्मी चौधरी अच्छा ठीक है नेक्स्ट हम पढ़े से अनुसार प्रस्तुत है क्या बहुत बहुत धन्यवाद
भाई सर बर्तमान कहि सालेनी जे हमर नेक्स्ट जो लेक्चर अछि सेथिरे मिस शुभलक्ष्मी चौधरी डिपार्टमेंट ऑफ सोशल साइंस सी लाइफस्टाइल एंड डिजीजेस इश्यूज एंड चैलेंजेस ऊपर कहिबे तेनो आपण मानको पुनी स्वागत करियो सेथिरे नेक्स्ट शुक्रवार वर्तमान धन्यवाद करबो और सिपाई मो ए प्रोग्राम रो को कोऑर्डिनेटर डॉक्टर विश्वजीत परिडान को अनुरोध करिबी धन्यवाद अर्पण करबा में
समस्त को नमस्कार Respected Vice Chancellor, Sri Santosh Kumar Tripathi sir, respected Chairman, the Postgraduate Council, Professor Santosh Kumar Agarwal sir, respected Speaker, Professor PRAKASH Chandra MISHRA sir, faculty members, media friends, research scholars. Good evening, one and all. It is my immense privilege to propose a vote of thanks on the first Intramural lecture. At the outset, I express my heartfelt gratitude to our beloved Vice Chancellor sir, Sri Santosh Kumar Tripathi, for his inspiring presidential address and his encouragement towards academic excellence. Thank you, sir. I extend my sincere thanks to Professor Santosh Kumar Agarwal, sir, Chairman Postgraduate Council, for his gracious presence and valuable words. Thank you, sir. I am deeply grateful to our speaker, Professor PRAKASH Chandra MISHRA, sir, for his enlightening lecture which has truly enriched our understanding of fluoride in drinking water and the technological approaches for the treatment of fluoride. Thank you, sir. I also thank Dr. Abhinav Behra, sir, coordinator of this program, for smoothly coordinating this session. Thank you, sir. Last but not least, I thank all the faculty members of various departments, research scholars, and media friends for making this talk successful. Thank you all.